All right, coordinate geometry, using coordinates. Obviously, this is the distance formula, the Pythagorean theorem, which I hope you will begin to see is the same thing as the distance formula. So if I wanted to solve this for C in terms of A and B, which really means just getting C by itself, I would have to take the square root of both sides. Okay, so if I took the square root of both sides like this, then that's going to give me, and I'm just going to go ahead and flip it around and put C equals the square root of A squared plus B squared. Now when my students do this, sometimes they want to just put A plus B. Like this square root is going to cancel out the these two exponents, but that is not the case. You cannot take the square root of each term when it's being added or subtracted. So that is the answer for number 1. Number 2, classify each triangle as equilateral, isosceles, or scalene. And we want to be as specific as possible. This first triangle is scalene because a scalene triangle has 3 different side lengths. This triangle is equilateral because all 3 sides are the same, man. So that's equilateral. And this one is isosceles. Isosceles. Because it has at least 2 sides that are congruent. Now, technically, this middle triangle is also isosceles by the way it's defined. I do want you to understand this. This is isosceles too. It's isosceles too because it does have a pair of congruent sides. And isosceles is defined as at least 2 congruent sides. So having a third side that's congruent makes it a special kind of isosceles triangle called equilateral. But if I asked you a yes or no question, and if I said, is this an isosceles triangle? Is this an isosceles triangle? Yes or no? You would have to say, yes, this is an isosceles triangle. Now, if I said classify this and be as specific as possible, you would go ahead and put equilateral to be specific. Now, look at number 3. It turns out that if you have lines that are perpendicular, their slopes are opposite in sign and reciprocal. Okay, do you remember what reciprocal means? So if I have 2/3, like we have to start off with, what would be the reciprocal of 2/3? The reciprocal of 2/3 is 3/2. But that's only part of it. If it's going to be perpendicular, the slope will also have the opposite side. So negative 3/2. It's got to be opposite in sign and reciprocal. That's how the slopes of perpendicular lines work. Find the distance between the 2 points. So show all work. It really just means to show the setup. So the distance between these 2 points will be square root of, and we'll do some x minus x. I'm going to do 3 plus 2 squared. Okay, x minus -2 is 3 plus 2. Plus, and now I'm going to do y minus y squared. So that'll be -1 minus 5 squared. I'm really just going to put that in my calculator. So, square root of 61. Alright, we're using the distance formula. We're experts at this by now. And same thing for number 5. So that's going to be the square root of and x minus x, so I'm going to do 2 plus 5 squared. Then y minus y, so I'm going to do negative 4 plus 1 squared. Again, minus and negative 1 is same as addition. Back to the calculator. Okay, radical 58 is what we should have gotten right there. Fantastic. So that is how you do number 4 and 5. Classify the triangle as scalene, isosceles, or equilateral. Here it says PD, DQ, and PD, but we have A, B, and C, so that's a mistake. Let's just cross this out and go with AB, BC, and AC. Okay, because that would make more sense with what we have. So AB, so that means we'll do our distance formula from A to B. So that's going to be x minus x. So I can do 4 minus 6 squared, and then y minus y. So that's 6 minus 1 squared. Just going to throw that in the old calculator. Square root of 29. So there's my square root of 29. BC. So I'm doing these 2 points right here, so that's going to be the square root of, okay, x minus x. So I'll just do 6 minus 1 squared. Now y minus y. So that'll be 1 minus 3 squared. Calculator time. Square root of 29 again. Alright, so it's definitely isosceles, but if the third one is square root of 29, then we will go more specific and say equilateral. Let's see what happens. Okay, so finally we're going to do AC. So x minus x could be like 4 minus 1 squared. Then y minus y could be 6 minus 3 squared. To the calculator, Batman. Check it out. So we get 3 radical 2, which means this is isosceles. We have 2 sides are the same, the third side is different. That is an isosceles triangle. Alright, looking at number 7. Now number 7 mentions midpoint, which is a simple concept, but kids still mix it up sometimes. So look, the midpoint is a point. The point in the middle point, the midpoint. I'm emphasizing that because, you know, the form of the midpoint is an ordered pair. I like to call it C comma D. Because I always look at this as A, B, C, D, and E, F. Anyway, so we're given endpoints. Let me change colors for a second. So we're given these endpoints. So one endpoint is negative 7, comma 1. Another endpoint is negative 2, comma 5. So we've got these endpoints. We're supposed to find the midpoint. So look, the way you find C and D for midpoint is averages. So basically, the middle x value is going to be the average of the x values from the endpoints. So C should be what I will get if I add up these x values and divide by 2. So negative 7 plus negative 2 divided by 2. That should give me my C value. My D value is going to be the average of the y's. The middle y value should be the average of the y values from the endpoint. So how did I do? I did negative 7, so I'll do 1 plus 5 divided by 2. Okay, so the c value is going to be negative 9 over 2. And this d value is going to be 6 over 2, which of course is just 3. So please put this back into the shape of an ordered pair. So c comma d is negative 9 over 2 comma 3. Do not leave this as two separate answers. And the order really matters because this is like x comma y, c comma d. The order matters, and it has to be in parentheses. Okay, so that is how you do that. If you remember that these are the average, for when you do the average, which makes sense for something that's in the middle, you always add them up and divide by 2. So that will help you not get confused and think we're going to subtract like we do for slope and like we do for the distance formula.